Welcome to lesson 4.7, use isosceles and equilateral triangles. So in past lessons, we were looking at congruent triangles and using congruency to prove that corresponding parts are congruent or equal, or to find missing measures. Now in this lesson, we're going to forget about just congruent triangles, and we're looking at isosceles and equilateral. Now remember, isosceles triangles are triangles where two or more sides are congruent. An equilateral triangle is a special type of isosceles where all three sides are congruent. So based on that info, we have two theorems. Theorem 4.7 is the base angles theorem, where it says if two sides of the triangle are congruent, then the angles opposite them are congruent. So if I look down here, if I knew side GH was congruent to side FH, that tells me the angles opposite those sides are also congruent. So the angle opposite FH is G. The angle opposite GH is F. So I know angle F would be congruent to angle G. And then we have the flip side of that, or the converse. Theorem 4.8, converse, a base angle theorem, tells us if we know two angles are congruent, then the opposite sides are congruent. So if we started knowing angle F and G are congruent, then we know their opposite sides, FH and GH, are also congruent. So the base angle theorem, if you know the sides, then the opposite angles are congruent. The converse, if you know the opposite, or if you know the angles, then the opposite sides are congruent. So example 1, name two congruent angles based on the info. So in triangle FGH, side FH is congruent to side GH. So just like we said before, our congruent angles would be angle FGH and angle HFG. So angle F is congruent to angle G, or angle HFG congruent to HGF. Then we get into the corollaries to these theorems. And remember, a corollary is kind of an extension or a conclusion we can draw based on a theorem that's pretty simple to come to. So the corollary to the base angle theorem says if a triangle is equilateral, then it is equiangular. So if all sides are the same, then all the angles are also the same. The corollary to the converse of the base angle theorem says if a triangle is equiangular, so if all three angles are 60 degrees, then the triangle is equilateral. So we know in equiangular triangles, if we're ever dealing with equiangular, we know that the individual angle measures are each 60 degrees. Because 180 degrees divided by 3 equal angles is 60 degrees per angle. So if we're looking to find the measures of R, S, and T, and we knew each side of this triangle was 3 meters, so it's already equilateral, we know the angles have to be the same. So R, S, and T each measures 60 degrees. Example 3. Find the values of x and y in this diagram. So what do we know in this diagram? We know triangle JKL is equiangular. So triangle JKL, the big triangle here, one big hash mark here, one here, one here. So angles KJ down here, KJ to L, and angle KLJ are all 60 degrees, which tells me that the big triangle JKL is also equilateral So if one side of that is 8, all sides of JKL have to be 8. So x in this case, the distance from J to L, is also 8. And then what else do we know? We know angle JML, so right here, JML, is congruent to angle LJM right here. So the two base angles of this triangle are congruent. So their opposite sides are also congruent, meaning 2y here is equal to this side here. So LM and LJ are both equal to 8. So that tells me 2y equals 8. Divide both sides by 2. Y would equal 4. So we're applying the theorems and their corollaries to then use the algebra to find our missing lengths. Then we get into everyone's favorite, couple proofs. So example 4, they gave us some info. Angle 1 is congruent to angle 2 and side AC congruent to side BD. So I went in and marked angle 1 congruent to angle 2, side AC congruent hash mark to side BD. Eventually, we're proving angle 3 is congruent to angle 4, so the two up here. So how do we get there? Well, they began with our statements. 1 and 2 are both from the given. So we know our reasons are given and given. Then they stated angle AEC is congruent to angle BED. So here and here. That's the definition of vertical angles or vertical angles congruence theorem. Both of them state vertical angles are congruent. So either one would work there. In 4, they used angle-angle side congruence theorem. Well, if I look, what do I know for angle-angle side? Well, I have angle-angle side of triangle ACE and angle-angle side of triangle EBD. So triangle AEC is congruent to triangle BED from angle-angle side congruence theorem. Then they went on to say side AE is congruent to BE. So AE here, congruent to BE here. The way that they could do that is by using corresponding parts of congruent triangles. And based on these two sides being equal, we can use the base angles theorem, or the converse of the base angles theorem. Which one would it be? Well, we know the sides. We're trying to find the angles. So we're just using the regular base angle theorem. So because we know that these sides are congruent, we know their opposite angles, 3 and 4, are congruent based on the base angles theorem. And then we get to our last example for today. Example 5 is completing each statement based on the diagram. So they told us angle PQ is congruent to PT. Then which two angles must be congruent? So PQ, the outside here, and PT, the outside here, are congruent. So they're opposite angles. Angle PQT on the back here, that big triangle, and angle PTQ on the back here would be the opposite angles that are congruent. If we start with angle PQV being congruent to PVQ, so PVQ, this angle here, and then PQV, this angle here, what two sides are the opposites? Side PQ and side PV, because we're looking at this triangle on the left. If RP is congruent to SP, so RP here, SP here, we're dealing with this little triangle in the middle, then I know their angles opposite are congruent. So angle PRS is congruent to angle PSR. If side TP is congruent to side TR, so TP and then TR, we're looking at this triangle kind of tipped sideways. So then we know triangle TPR is isosceles, meaning angles TPR and TRP are congruent. If PSQ, angle PSQ, is congruent to angle SPQ, so PSQ and SPQ, then we know their opposite sides must be congruent. So opposite PSQ would be QP, and opposite PQS would be QS. So in that case, QS and QP are congruent. And last but not least, if angle PUV is congruent to angle PVU. So PUV there, PVU there. So we're kind of looking at this bigger triangle in the front middle, triangle PVU. Then we know that side PV is congruent to side PU. So these here are using our base angle theorem and the converse to identify the different triangles in this image and find the opposite angles or opposite sides. But the whole idea for this lesson kind of comes back to these first two theorems and then the two corollaries here.